Hi, coming to you late night, Sunday, early Monday morning, August 17th. Today we're going to keep working on composite functions, but we're going to bump it up a notch, kick it up a notch, as they used to say. And the equations are going to be a little bit more challenging, and it involves using a skill where you know how to solve a quadratic inequality or a nonlinear inequality. So let's get started. Got the mean streets of New York behind me. Alright, so find the domain of a function. Now last week we talked about finding the domain of a function, and these were the rules that you needed to follow in order to be able to calculate the domain. It's only when you have one of these situations that you've got to worry about calculating the domain. So if you have a denominator that's got a variable in it, if you've got an expression underneath a radical, that's called a radicand, that's got a variable in it. If you've got both of those, a radicand that's inside or in the denominator, or if you have a logarithm, the argument of that log, whatever is here, has to be greater than or 0. Okay, that's the definition of a log. But we'll get into logs later on. Alright, so in order to be able to do what we're doing today with domains, you've got to be able to solve a nonlinear inequality. Okay, so that's something that's, instead of having an equals, it has a greater than or less than. In our case, it's always going to be greater than, because we're going to be dealing in situations where the function has to be 0 or larger. Alright, so first thing is, if I wanted to graph or if I wanted to find what makes this expression here not equal to 0, well, that's simply going to be whatever makes each one of these expressions not equal to 0. So in this case, I don't want x plus 2 to equal 0, so x can't equal negative 2. And I don't want x minus 3 to equal 0, so x can't equal positive 3. Now you can solve this right away just by looking at the graph. All right, so if we looked at Desmos' graph of this, which is this right here, I just typed it into Desmos, we can see that when I want to look for something where it's not equal to 0, that's telling me the 2 points that it is equal to 0. So I know in order for this not to equal 0, I can't have negative 2 and I can't have negative 3. So it's simply just the x-intercepts. Now, if I was going to write this in interval notation, so I drew a number line and I marked on it the two zeros, negative 2 and 3. The graph can be the values in this can be anything except those two, so that's why I put an open circle on them. Now all you do is you just write the intervals that are shown here. So this divides the number line into 3 intervals. Okay, this interval on the left here would go from negative infinity up to, but not including, negative 2. So that would be a parenthesis. And then the next area would be right in between these two. So I would put that with negative 2 to 3, but again, it doesn't include either one of those, so I use parentheses. And then finally, 3 to the right of 3 up to infinity. So I'm just writing the intervals for each one of these parts here. So any place where this graph doesn't equal 0, okay, that's the two ends right here, and then this middle section, that equals the section that's between 2 and 3. So that's by just looking at the graph and getting what it is. Okay, getting the parts of the graph that aren't equal to 0. Anything in that, any x-coordinate would make that inequality true. All right, now, once you've got this drawn, doing it for greater than or equal to 0 is really easy. Okay, if you look at this graph, where this graph is greater than or equal to 0, well, if you just look at it, it's any part of this graph that is above the x-axis. Okay, so this part of the graph is greater than or equal to 0. And this part of the graph is greater than or equal to 0. So what that tells us is that from negative infinity up to and including -2, this graph is positive. From 3 out to positive infinity, this graph is positive. So I can say, if I was going to represent this on a number line, okay, now it's allowed to include -2, so I'm going to have a solid dot at -2. Or, excuse me, it's allowed to be equal to 0. So at -2, this function is equal to 0. Okay, then I'm going to have a solid dot at +3. Okay, and where this graph is positive, I'm going to put a plus sign. Okay. So from negative infinity up to and including -2, this graph is positive. Okay. In between -2 and 3, the graph is negative. And to the right of 3, the graph is positive. So to take that and write it in interval notation, like I just said a few minutes ago, that would be from negative infinity to -2 with a bracket, or from 3 to positive infinity. Now the last one is, well, when is this greater than 0, not equal to? Well, it's going to be the same as this. The only thing I do is I just take away the brackets and I make them parentheses. And anything in either one of those intervals would satisfy that inequality. And if I had a diagram here, the only thing that would be different is that these would be circles. Okay, if I was putting my positives and negatives on it, it's greater than 0 there, it's greater than 0 to the right of 3, and it's less than 0 between the two. So that's using a graph to solve nonlinear inequalities. Now you do that to get the domain. Okay, now the other way that you can do this is you don't have to graph it. Okay, you can use what's called a sign chart. Okay, so to do a sign chart, there's two things that you put on there's just one thing you need to worry about right now to put on a sign chart, and that's the x-intercepts. All right, or the zeros. So when I look at this, I've got an x-intercept that is -2, and I've got an x-intercept that's +3. So I plot those two on here, just draw a line. Then what I'm going to do is I'm going to take the two factors here, x plus 2 and x minus 3. I'm going to write them right over here by this on the side. Okay, and Okay, so what these two do, these two zeros, is that they divide this into 3 different areas. So you want to know, is the graph positive or negative in those areas? And you don't have to look at the graph in order to do it. You can figure out by looking at the signs. Alright, so what you do is you pick a number to the left of -2, like -5. I'm going to put -5 in for x here. When I do that, this factor is going to be negative. -5 plus 2 is negative. -5 minus 3 is also negative. Now the result of this, since these two things are being multiplied, is I get a negative times a negative, so it's going to be positive. Okay, if I pick a number between -2 and 3, like an easy number, like 0, okay, I'm going to put 0 in, and 0 plus 2, that's positive. 0 minus 3, that's negative. So now the one term would be positive, the other term would be negative, and when you multiply those, you get negative. Alright, now over here, I'm going to pick a number greater than 3, like 5. Okay. So now if I put 5 in, 5 plus 2, that's positive. 5 minus 3, that's positive. And a positive times a positive is positive. So here, I know my graph is greater than 0. Okay, I know here the inequality is greater than 0. And then in between these, my inequality is less than 0, because it's negative. Okay, so to solve this, okay, if we were just asking where doesn't it equal 0, we don't care if it's positive or negative, just not 0, then all I got to do is write these 3 intervals down, and I don't include -2 or 3. Right? So this interval here on the left, okay, that would be from -infinity to 2, but not including -2, or in between -2 and 3, but not including either one, or from negative or from 3 to positive infinity. Any number in either one of these 3 intervals would make this inequality not equal to 0. Okay, once you've got that done, then doing the next 2 is really easy. Okay, if I don't want it equal to 0 or greater than 0, all I do is leave these as parentheses. So the 2 areas where it's greater than 0 are these 2 sides. So I'm going to write this. The one place where it's positive is from -infinity to -2, but don't include it because I don't want it equal to 0, or from 3, not including 3, up to infinity. Now the only difference is when I do the bottom one here, I want it greater than or equal to 0, so all I'm going to do is change that parenthesis in this one to brackets. And there are my intervals that make those true. Any number you pick in these 2 intervals would make this thing greater than 0. Any number you pick in either one of these 2 intervals would make the expression greater than or equal to 0. All right, now to do the domain of these, well, this is where you start using the rules from the other day. If I've got a denominator that's got variables in it, I'm going to set it not equal to 0. So this first one here, I don't care about the numerator. All I care about is the denominator. So I want to know, well, what intervals is this not equal to 0? Well, we already did it when we solved it right here. It's the same thing. So that's done. So we can just take that and put it right here. All right, when we've got a radicand under an even radical, then we know that this has to be, it's allowed to be greater than or equal to 0. That's this rule right here. So I want to know where's this graph positive? Well, or equal to 0, which we did right here. So the radicand is, to get the domain of this, that radical, the result of this is allowed to be 0 or positive. So we're using that domain that we did a few minutes ago. Okay, so when it's equal to, remember you're going to have a bracket now. This would be negative 2, negative infinity, or 3 to positive infinity. Okay, that's this one right here. And then the last one, when I've got a radical that's in the denominator, well, all you're doing the same thing. You're just getting rid of the equal sign. That's the only difference. And so all that means down here is you're just changing a bracket for a parenthesis. So that bracket becomes a parenthesis. And there are my domains. All right, put this equation, I took this inequality here, this quadratic, and graphed it in Desmos, and this is what it looks like. So I want to know, when does this graph not equal to 0? Well, it's only equal to 0 at these two places. So every other place, it's not equal to 0. So any x value that would be in any one of these three areas here would solve the inequality. Okay, so just by looking at this graph, okay, this part of the graph doesn't equal 0, so that's going to be from negative infinity up to, but not including, negative 1, because this graph can't equal negative 1, so that should be a parenthesis. This graph is also non-zero between negative 1 and 5. Okay, that's this whole area. This part of the graph is non-zero, and then the last part is negative, so that's non-zero, and we represent that by parenthesis 5 to infinity. And that would be the solutions for that inequality. All right, the next one's asking you, well, where is it greater than or equal to 0? Well, that's the blue part. So in between -1 and +5, this graph is positive. So, and it's allowed to equal 0, so that's why I use the two brackets. And now where is it just greater than 0 but not equal to it? Well, I just switch those brackets for parentheses, and any number between -1 and 5, but not including those, would make this inequality greater than 0. All right, now if you were doing this and you weren't graphing it, okay, so we're going to use the sign chart method. Okay, now if we're solving this with using a sign chart, okay, now this one's a little tricky because there's a negative in front of the squared term. So one thing you can do is you could divide everything in these equations by -1 and then solve that resulting equation. So now I would have x squared minus 4x minus 5 does not equal 0. Now when you do that down on the second one, remember when you divide by a negative or multiply by a negative, you have to flip the inequality. So on this second one, I'm going to have x squared minus 4x minus 5, but instead of greater than or equal to 0, to solve this inequality, I'm actually going to solve the inequality that's less than or equal to 0. Doing that will give me the answer to the greater than or equal to 0. And then the same thing is going to be true down here. When I divide this by -1, I got to remember to flip the inequality. All right, so by solving these new versions, I'll solve my original versions. Okay, so we factor this. This would factor into what multiplies together to be -5 and adds together to be -4, and that would be -5, +1. So over here on my sign chart, my two zeros are going to be at -5 and at +5 and at -1. Okay, so if I don't want these equal to 0, I put an open circle there. Now every other section of this number line, to the left, to the right, and in the middle, the graph would be, or the value of this would be non-zero. Might be positive, might be negative. Okay, so to describe that, I would say where it's not 0 goes from -infinity, -1, then in between the two, and again I'm using parentheses because I don't want to include the zeros. And there's my answer to that inequality. Now for the next one, I want to know, in order to know where this graph is actually greater than or equal to 0, I solve this inequality that's less than or equal to 0 because I divided everything by -1. So I'm going to write my factors up here. X minus 5, x plus 1, and now I'm going to choose values from each one of these three intervals. So I want a number to the left of -1, like -2. -2 minus 5 is negative. negative 2 plus 1 is negative, and that area is now positive. Pick 0, let's say test, so in here I'll just test 0. In this first one, my test number was negative 2. And then over here, we'll test a number bigger than 5, like, I don't know, 7. So let's do the 0. 0 take away 5, negative. Okay, 0 plus 1, positive. And then a negative times a positive is negative. And then pick 7. This is positive, positive, positive. So the areas where it is negative, where it's less than or equal to 0, is right in between here. And I use brackets because it's allowed to equal 0. So this interval would be bracket negative 1, 5. And then for the following one, it would simply just be negative 1 parenthesis 5 parenthesis, because the 0 is not included. Okay, so then it just, we've done, once we solve the inequalities, you've got the domains. So in this next one, I don't care about the numerators. I just took whatever the denominator is, it can't equal 0. So that was the same as this solution here. The next one was the radicand has to be greater than or equal to 0. And that was true on this interval. And then this, if it's in the denominator and in the under the radical, a double whammy, then you just take off the bracket and change it to parentheses, because it's not allowed to equal 0, but it has to be greater than. And there's your domain. So if you can solve inequalities, you can solve domains that have nonlinear terms in them. These are all nonlinear. They're parabolas in this case. Okay, all right, this last section, you can pause the video, try to solve them, and turn it back on and see how you did. All right, let's see how you did. This first one, the denominator can equal 0. So I factored that. That's the difference of two squares. So x minus 2, x plus 2. So my two zeros are going to be 2 for this one and negative 2. It can't equal 0, so it can be any one of these three intervals as long as it's not equal to either one of those numbers. Okay, so there's my domain for number 1. Okay, number 2, the radicand has to be greater than or equal to 0. That again is the difference of two squares, so it factors into x minus 7, or 7 minus x, and 7 plus x. So my two zeros are 7 for the first one and negative 7 for the second. This is allowed to be equal to 0, so I put in two solid dots. Right? And then I took my two factors and I chose a test number from each one of these three intervals. So less than negative 7, like negative 8. You plug negative 8 in, you get a negative, and you get, oh, that's two negatives. Wait a minute, whoops, this is wrong. That should be a positive, and this one should be a negative. Glad I caught that. Okay, still negative. If I put a 0 in, I get a positive and a positive, and if I put an 8 in, I get a negative and a positive, which is negative. I'm interested in the area that is greater than or equal to 0. That's the positive part. So my interval, my domain is from negative 7 to 7, including. And then the last one, here's a radical or a quadratic that is in the radical in the denominator. That's the double whammy, and so it's just got to be greater than 0. So I factored it. My roots are 7 and negative 3, and I want to know where it's greater than 0. So I put two circles there, and then I chose three test numbers. to the left of negative 3, that's negative 11. That's negative 1. So when you multiply them, it's positive. 0, 0 minus 7, negative. 0 plus 3, positive. Multiply them, you get a negative. And then when you put 8 into both of those, you get 2 positives. So it's positive. So the 2 highlighted areas are greater than 0, and I don't include the 2 numbers, so I use parentheses. And that's how you get domain. So you can use graphing and read the graph of the denominator when that's the situation, or you can use a sign chart. So for today, you're going to do Math Excel number 7, please. This will be due Wednesday night, and that's all we got today. So I'll see you next time. Bye-bye.